Hello friends, welcome to Learn Easy. In this session, we will discuss about the rational number, whether terminating decimal or non-terminating but repeating decimal. We know real numbers are divided in two parts, rational number and irrational number. So we will discuss today only with rational number. Rational number, whether terminating decimal or non-terminating but repeating decimal. Let us start with the rational number. X is equal to P by Q. Now, if the prime factorization of denominator Q is in the form of 2 to the power n, 5 to the power m, where n and m are non-negative integers. Then x has a decimal expansion which is terminating. That means the denominator Q will be in the form of 2 to the power n, 5 to the power m, where n and m are non-negative integers. Then this rational number x has a decimal expansion which is terminating. Second point, if the prime factorization of the denominator Q is not in the form of 2 to the power n, 5 to the power m, where n and m are non-negative integer. Then x has a decimal expansion which is non-terminating. But repeating. Repeating means recurring. without actually performing the long division, it can be stated that whether the rational number have a terminating decimal number or non-terminating but a repeating decimal number. How? Just examining the denominator, whether it is in the form of 2 to the power n, 5 to the power m. If it is in the form of 2 to the power n, 5 to the power m, then it is terminating, decimal expansion is terminating. If it is not in the form of 2 to the power n, 5 to the power m, or any extra factor is there, then it is non-terminating but repeating. If any number is neither terminating nor repeating, then the number is irrational number. Which we have discussed in other session. As for example, root 2, root 5, etc. Some, without actually performing long division, state whether the following rational numbers will have terminating or non-terminating but repeating decimal. Just we have discussed just now. In that way, we will do this sum. First one is 13 by 3125. So here denominator is 3125. We'll factorize it. So we can write here 13 by 3125 is equal to 13 divided by 5 to the power 5. Again, it is equal to 13 divided by 2 to the power 0 means 1 into 5 to the power 5. So the denominator is in the form of 2 to the power n, 5 to the power n. Therefore, the rational number x is terminating decimal. Second sum is 64 divided by 455. Let us factorize the denominator. (64) divided by 5 into 7 into 13. Here the denominator is not having in the form of 2 to the power n into 5 to the power n. So we can conclude that since it has extra factor 7, 13, therefore the rational number (64 by 455) is not having terminating decimal but have repeating one. Is 129 divided by 2 to the power 2 square, 5 to the power 7, 7 to the power 5 into 5 to the power 7 into 7 to the power 5. Here here denominator is already factorized, so we can directly conclude since the denominator is not in the form of 2 to the power n into 5 to the power m, it has other factor 7. Therefore, the rational number is non-terminating but repeating. Number 4 sum is 27 by 210. 27 by 210. Is equal to 9 by 70. Is equal to if we factorize 70, so 9, 2 into 5 into 7. Again the same logic as it is here, since the denominator is not in the form of, here you see 2 to the power n, 5 to the power m is there, but there is also another factor 7. That's why it is non-terminating but repeating. The denominator is not in the form of 2 to the power n, 5 to the power m. It has other factor 7 also. Therefore, the rational number is non-terminating but repeating. So now it is clear, without doing long division, how we can find out the fraction is having non-terminating decimal number or terminating decimal number. Non-terminating but recurring decimal number. The following number have decimal expansion as given below. Decide whether they are rational and of the form of p by q. What can be said about the prime factor q? Numbers are given. Solution will be 4, 3.1, 2, 3, 4, 5, 6, 7. If we examine the number, we will see that it is terminating decimal. So, we can conclude the given rational number is having terminating decimal expansion. What can be said about the prime factor q? When it is terminating decimal expansion, therefore prime factor of the denominator q is in the form of 2 to the power n into 5 to the power m, where n and m are non-negative integers. Now the second sum is, this is 0.120, 12000, 0.120, 1200. Here if we examine, the decimal expansion is non-terminating and also non-repeating. So we can conclude that therefore the given number is irrational number. The third sum is 43.123456 recurring. recurring. Here we can conclude, since the decimal expansion is non-terminating but repeating. Therefore, the given number is rational in the form of P by Q, but Q is not in the form of 2 to the power n into 5 to the power m only. That's all. Thank you.